Good morning, children. Sairam. Children, today I'm starting with the next chapter, that is chapter 7, that is the D and F block elements of the periodic table. Now, children, we'll start with the introduction part. D block elements are actually the elements which are present in group 3rd to group 12th of the periodic table. That means this group 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th and 12th. All these elements which are present in these 4 rows, 21 to 30, 39 to 48, 57 to 80 and 89 onwards. These elements are called the D block elements. Children, D block elements are sometime, as you all can see, there are 4 series in the D block element. The first series from scandium to zinc is called the 3D series. Why it is called the 3D series? Because the outermost electron enters the 3D subshell. Similarly, from ytterbium to cadmium, it is 4D series. From lanthanum to mercury, it is 5D series. And the last one is called the actinium series, that is the 6D series. Children, all these elements which are present in the D block of the periodic table, they are called the D block elements because the outermost electron is present in the D subshell. Now, many a times we call them the transition elements also. Now, why do we call them as the transition elements? What are actually transition elements? Transition elements are the D block elements which have completely filled d orbital in it. Sorry, it's not completely, it is incompletely. Incompletely filled d orbital in its ground state or in any of its oxidation state. So, these elements which have incompletely filled d orbital in ground state as well as in its most stable oxidation state, they are called the the transition elements. Now, children, if we see to the electronic configuration of these elements, say for scandium, the electronic configuration is 3d1 4s2. For titanium, 3d2 4s2. But if we see to copper, it is 3d10 4s1. That means the d orbital is completely filled. But still, copper is a transition element because though the d orbital is completely filled in its ground state, but if we see to the most stable oxidation state of copper, it is 2 positive. For 2 positive, the configuration will be 3d9 4s0. So, here in most stable oxidation state, it is incompletely filled d orbital. So, it is a transition element. But if we see to zinc, in case of zinc, the most stable oxidation state is +2. In the ground state, you all can see it has completely filled d orbital, and in the most stable oxidation state also, the 2 electrons which are present in the s orbital will ionize and go out, but the d orbital will remain as such. So, the element zinc is not called as a transition element. Similar is the case with cadmium and mercury. They all have fully filled d orbital, that is d10 configuration. So, they are not called the transition elements. Now, you all can see the electronic configurations of the elements from ytterbium to cadmium. Cadmium again has D10 configuration. Mercury also has D10 configuration. And when they show their most stable oxidation state, the 2 electrons which are present here and here in the 6s and 5s subshell, the two will ionize. So these elements are not called the transition elements. Now if we come to the general properties of transition elements, then you can say all the transition elements are metallic. They show typical metallic properties such as they have high tensile strength, they are ductile. You all know the meaning of ductility, malleability. They have high thermal and electrical conductivity, which is a typical property of a metal. They have lustre like metal. They are shiny, with the exception of zinc, cadmium and mercury. Zinc, cadmium and mercury, as I have already told you, are the non-transition element. They are present one after the other. Just a minute. They're all present one after the other in group 12 of the periodic table, and they show certain properties which are not similar to the other members of the period. Now children, you have to remember, here we are not studying the D block elements according to the groups as we used to do in case of P block elements. P block elements we have to study like this: these elements, these elements, these elements, these elements. But now the D block elements we are studying in 3D series, 4D series, 5D series and 6D series. Like this we have to study. So, as I have already told you about the metallic property, now coming to the variation in the atomic size. Now children, as you all can see in the graph, that as we move from scandium to zinc, or you can say as we move from left to right in the periodic table, the size of atom increases up to nickel, or you can say palladium, platinum, but after that it starts increases. First of all, it decreases, after that it starts increasing. It is because the effective nuclear charge, you can say, the size is decreasing, effective nuclear charge is increasing, because but from here the size starts increasing because the electron pairing gets started. First of all, here all unpaired electrons are there. The effective nuclear charge increases with the increase in unpaired electron. But when pairing starts, then the size keeps on decreasing. Now coming to the ionization enthalpy. Children, due to the increase in the effective nuclear charge, which accompanies the filling of the inner d orbitals, there's an increase in the ionization enthalpy among each series of the transition element from left to right. That means the ionization enthalpy is increasing. You all can see through this table the values of the first, second and third ionization enthalpies. Now if we see to the elements scandium, titanium and vanadium, the ionization enthalpy is increasing in each step, and there are certain variations in that also, and here it keeps on increasing. The ionization enthalpy is increasing with the exceptions of few due to the presence of fully filled or half filled extra stable configuration, and the first, second and third ionization enthalpy also you all can compare. Now coming to the oxidation state. Oxidation state, you all know, that is the charge which comes on the metal when all the other elements which are forming a bond with it are removed. Now, one of the very noticeable feature of transition element is their great variety of oxidation state. Transition elements can show a great variety of oxidation state ranging from +2 to +7. Now, why they can show great variety of oxidation state? Due to the presence of incompletely filled d orbital. Now, if we see to scandium, it can show only one oxidation state, that is +3. But zinc also will show only one oxidation state, that is +2. Now, Scandium is a transition element, but zinc is not a transition element. Now, many a times in the board exam also a question comes, name the transition element which can show only one oxidation state of 3D series. So you have to remember, don't write down zinc, you have to write down scandium. Zinc is not a transition element. Now if we move from scandium to manganese, you all can see the oxidation states are increasing. That means manganese can show +2, +3, +4, +5, +6 and +7. Many a times in the board exam the question also comes, which elements can show, name the element of the 3D series which shows maximum number of oxidation state. So you have to remember that is manganese. Now from manganese onwards, if we move towards zinc, the number of oxidation states decreases. It is because pairing of electron is starting. Now coming to the magnetic properties. Children, these D block elements, they show magnetic property. Mainly two types of magnetic behavior are observed, the diamagnetism and paramagnetism. Diamagnetic substances are those which are having all the paired electrons and they are repelled by the magnetic field. There is no magnetism observed, you can say. They are repelled by the magnetic field. While paramagnetic substances are attracted towards the magnetic field. Paramagnetic are those which have unpaired electrons. Diamagnetic are those which do not have any unpaired electron, all electrons are paired. And ferromagnetism is the extreme form of paramagnetism. That means when many unpaired electrons are there, then it shows ferromagnetism. Now, many transition elements are paramagnetic. Why they are paramagnetic? Because of the presence of unpaired electron. Now, paramagnetism, it arises due to the presence of unpaired electron, and the magnetic moment is determined by the number of unpaired electron and is calculated by using the formula mu is equals to √n plus 2, where n are the number of unpaired electrons. Now children, the magnetic moment increases on increasing the number of unpaired electrons. Now we have calculated the magnetic moment. You all can see for scandium 3 positive, the configuration is 3d0. No unpaired electrons, so no magnetic moment. Similarly, if you see to the case of manganese 2 positive, 3d5, that means maximum 5 unpaired electron. So the magnetic moment calculated is also very high. The observed one is quite different from that. Now zinc, or you can say copper, if you see, then copper has 9 electrons, but the number of unpaired electrons is only 1. So the magnetic moment is also less. Now children, transition elements, they are capable of formation of colored ions. The compounds of transition elements are mostly colored. It is because when light falls on the transition element, then DD transition takes place. That means they absorb energy from the visible region of the electromagnetic spectrum, and they of certain particular frequency and show the color which is complementary to it. So if a question comes, why the compounds of transition elements are colored, you can say due to DD transition. This is just for explanation, no need to write. Now, transition elements, they are capable of forming the complex compounds also. Why they can form complex compounds? Because of the ability because of the small size of the metal ion and the availability of vacant d orbital. Now they have vacant d orbital, they can accept the lone pair of electrons donated by the ligands, so can form the coordinate bonds. Now, D block elements, they are also used as a catalyst. Why? What are catalysts? Catalysts are those which substances increase the rate of chemical reaction. Now, how they increase the rate of chemical reaction? By providing surface area for the reactant to react and form the product. Now, how transition elements can behave as catalyst? It is because of their ability to adopt multiple oxidation state, and they form temporary bonds with the reactant and the product. Now, they can form interstitial compounds also. What are interstitial compounds? Interstitial compounds are those which are formed when small atoms like carbon, hydrogen and nitrogen, they're trapped inside the crystal lattice. Usually they're non-stoichiometric. That means their compound, the formula of the compound does not actually have the same arrangement inside the compound. They're neither ionic nor they are covalent. Now, transition metals can form interstitial compounds with many of the elements. The examples are TIC. TIC, like titanium is there and carbon is there, like with titanium is forming with carbon. According to the formula, with each titanium atom one carbon atom is there, but actually it is not so. The stoichiometric formula, this is not the stoichiometric formula, you can say, and they also do not correspond to the normal oxidation state of the metal. Now, these compounds have certain important properties that you have to remember, like they have high melting point, they're very hard, they retain the metallic conductivity and are chemically inert. These are the properties of your interstitial compounds. Now, the last topic of your D block element is the alloy formation. You all know alloy are the mixtures of elements. An alloy is a blend of metals prepared by mixing the components. Now, transition elements, they are capable of alloy formation due to their similar radii. Their atomic radii are almost similar. There is not much difference between the alloys, so they can easily form the alloys. Now, the best known ones are the ferrous alloys. Now, iron is alloyed with many other substances like chromium, nickel to form steels of various types. Now, some of the transition elements, they can combine with the non-transition elements also and form the alloys. Like for example, brass. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Such alloys are also there. Now children, the last topic of your D block element was previously some of the important compounds of transition elements, in which you were to study the preparation properties and uses of potassium permanganate and potassium dichromate. But it has been removed from the syllabus. So your D block elements is over. In the next presentation, we'll start with the F block elements, or you can say the inner transition elements. Thank you and Sairam.